Edit. Alrighty. So if you're tuning in and watching this from the playback on YouTube at some point later, I'm probably going to want to fast forward. I'm just going to give a few moments to folks who want to join, who are watching live. So feel free to fast forward if you want to skip all that. I'm just going to give a couple minutes. Bum, bum, bum. Okay, so we are going to be learning about Docker today. So I'm a little bit familiar with Docker. I know that's like a containerization software similar to what you'd see like in a standard VM. But unfortunately for me at work, I'm kind of not very exposed to technology that other people are using in the real world. We kind of build our own stuff there. So we have our own build system and everything like that. So unfortunately, I'm not exposed to what you guys are all probably using. I'd like to learn a little bit more about Docker, how it works, and everything about that. So that's what this video is going to be about. Just taking it from a kind of fresh perspective, and we're going to run through the docs here and talk about what we read. Also going to take some notes so that we can kind of keep a tab on the important bits that I want to remember later. And feel free to add if you have any questions or anything that I'm missing through this. Feel free to drop a note in the chat. So I thankfully already installed Docker. I should close all these windows here. What's this one? Oh, that's a different thing. So I already installed Docker. I have it running, but I'm just going to kind of go through the motions here. So if this is your first time, you probably want to already install Docker. So go to the docs.docker.com website and go ahead and get it. You can get it for Mac, Windows, or Linux. It's probably easier to use Homebrew if you're on Mac, and just sudo apt-get for Linux if you're on Ubuntu. But I already have it installed on Windows. If we see my bottom right tray here, we see we have Docker. If I right click this guy, go to dashboard, you'll probably be able to see I've been messing with this a little bit. So let's just get rid of everything here. So assuming you have everything installed, we're going to move on to the get started section. We're just going to run through the overview here. So estimated reading time 10 minutes. That's good. I don't want to spend too long on this. Okay, that's weird. Anyways, so let's run through what's going on. Hershey, great channel. I love your content and very clear and practical examples. Keep up the great work. Thanks, man. I really appreciate that. Everyone's been super supportive, and I really appreciate the kind words. I do appreciate it. Anyways, so moving on. So Docker is an open platform for developing, shipping, and running applications. Enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. So like kind of the way I'm understanding this so far is that it's just a wrapper for your development environment. But let's keep on going and see what else we got. So the platform provides you the ability to package and run an application in a loosely isolated environment called a container. Okay. The isolation security allow you to run many containers simultaneously on a given host. Containers are lightweight because they don't need to run extra load of a hypervisor, but run directly within the host machine's kernel. This means you can run more containers on a given hardware combination than if you were using virtual machines. You can even run Docker containers within host machines that are actually virtual machines. So what this is effectively saying is that, if say, for instance, you have a 16 gigabyte machine, you can kind of slice that up into, I guess in the best case, 8 2 gigabyte machines, and obviously you can allocate different amounts of CPU to each. but you can kind of isolate or shard out your machine into different instances, and each container seems to have its own resources. So let's keep on going. Provides tooling and a platform to manage the lifecycle of your containers. You develop it and its supporting components using, okay, this is fine. I'm not going to go through that. Now what are we talking about? Okay, so this is the interesting bit. So the Docker engine. So the Docker engine is a client-server application with these major components. A server, which is a type of long-running program called the daemon process, the docker d command. And a REST API, which specifies interfaces that programs to use to talk to the daemon and instruct it what to do. Okay, so what do we have? So we have a daemon, like a Docker daemon, right? That's what it's saying. Let me know if you guys can't read the notes here on the right. Then you have a REST API to interact with it, right? And then a CLI to, I'm not sure if you're outputting like REST commands when you're using the CLI or what, but you have a CLI to interact with it also. Interact with it. So what do we got here? What is this? So network. So we have the server Docker daemon. So if I start up a container on this machine, it's going to start this daemon. Then we have a REST API layer that interacts with the daemon. And then from the client perspective, what is this saying? We have images. So the client manages the images, the client manages the container, the client manages the network, and the client manages the data volumes. So if I understand correctly, the images are just kind of snapshots of different configurations. So say, for instance, like a Tomcat server or like a Node.js app on Express or something like that. And the container is actually like the virtualization of that image. So the local installation of that. So that's my understanding so far. So the CLI uses Docker REST API to control, or, okay, here we go. So the CLI uses the REST API. So let me just add to these notes. CLI to interact with it uses the REST APIs. Okay, through scripting or direct CLI commands, many other Docker applications use the same, use the underlying API and CLI. Manages Docker objects such as images, containers, networks, and volumes. It's licensed, Okay, so what can I use Docker for? Fast, consistent delivery of your application. So it streamlines the development lifecycle by allowing developers to work in standardized environments using local containers which provide your applications and services. Containers are great for continuous integration and continuous delivery, CI/CD workflows. And if you don't know what CI/CD means, it's just basically, you have a pipeline, development pipeline set up in such a way that you're so confident in it, you have solid unit tests, solid integration tests, solid everything around it, that you're so confident in that setup that you can just hook it up such that when you push a commit to your Git repository, it'll auto build, run all your tests, and just deploy it straight to production. So that's like kind of the most desirable state for any kind of developer. It's to have a CI/CD setup. Unfortunately, these are very hard to come by, and they're very hard to maintain because you need to keep your unit tests up to date, make sure you got good coverage. You need to do the same thing with your integration tests, make sure your integration tests cover all your major business use cases, but that's the value of CI/CD. So it seems like what they're saying here is that they streamlined the development lifecycle by allowing you to create a container that closely mimics what you'd have in production. So you can easily kind of figure out what would happen in prod if you were to deploy your application in prod. So here's a scenario. Your developers write code locally and share their work with their colleagues using Docker containers. They use Docker to push their applications into a test environment and execute automated and manual tests. Okay. When they find bugs, they can fix them in the development environment and redeploy to the test environment for testing and validation. When testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. So I'm not really too sure how this differs from like a traditional just like build and deploy cycle, except that we're just using Docker in between. But maybe we'll figure that out. So moving on here, so responsive deployment and scaling. So it's a container-based platform, allows for highly portable workloads. Containers can run on a developer's local laptop or physical or virtual machines in a data center, cloud providers, or a mixture of environments. So this is really one of the selling points that at least I'm aware of. Whenever people say Docker to me, the first thing I think of is, well, I compare it to Java, which is, if you're not familiar in the history of Java, Java is kind of hardware independent, so it'll work on, if you're on different types of CPUs or different types of hardware, it doesn't matter, you'll still be able to run Java on all of them. That's kind of the appealing factor. Whereas with languages of C, like C and C++, you're going to have hardware specific variations of the language. So this is kind of what Docker seems to provide, is a generic like hosting infrastructure for your applications that can be done locally, and it can just be ported over to any environment that you want. And if you're just joining, thanks for joining, guys. Feel free to ask any questions or correct me on any assumptions that I'm making here. So I know a little bit about Docker, just used it very lightly, but going to be poring over the docs here to understand it a little bit better. So moving on, so its portability and lightweight nature also make it easy to dynamically manage workloads, scaling up or tearing down applications and services as business need. So just to give you kind of I'm kind of anticipating what they're going to say next, but how I can see this being useful is the fact that if you can deploy instances of your application in these like little modules, these little containers that are completely independent of one another, it's very easy to scale up, so scale horizontally to serve more traffic, because you can just add more containers, right? And since they're identical, they can either be on the same machine or different machines. It doesn't really matter in the Docker world, right? Because even if it's on the same machine, it'll act in the same way as if it were on a different machine. All you really need to do is set up load balancers so that the requests are being routed to the right machines and on the right ports that your application is running on. So that's kind of what I can foresee as them saying as the main benefit. So it's lightweight and fast, provides a viable, cost-effective alternative. Is Docker free, by the way? I'm pretty sure it's free. I don't think there's any cost mechanism. So how do these guys make any money? I don't really know, but maybe someone can tell me. If you know how Docker makes money, tell me. So you can use more of your compute capacity to achieve your business goals. Docker is perfect for high density environments, for small and medium deployments where you need to do more with fewer resources. Okay, that's fine. So architecture. So let's see what they're saying here. It uses a client-server architecture. Docker client talks with a Docker daemon. So we already have that in my notes section, which does the heavy lifting of building, running, and distributing your Docker containers. Okay. So the daemon is the background process that's running. And I guess you interact with the daemon through, they had the picture up here, through the API, and the CLI interacts with, like, you call methods using the REST API. So that makes sense. Where was I? Here. So the daemon, it does the heavy lifting, but you issue commands to the daemon so that it can do the right thing. So it manages running and distributing your Docker containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. Okay. So remote Docker daemon. So you have a daemon running on a different machine and you're connecting to it. So that's pretty interesting. I want to write that down. So what did this say? So your Docker daemon can run on a totally different machine and you can issue commands to it from your local, all right? By the way, if you're interested in these notes, let me know and I can make them available. I'll put them up on GitHub or a Gist or something. So the Docker client and daemon can run on the same system. Okay, got that. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface. Okay, so what do we got here? So we have a client, Docker build, Docker pull for pulling images, and Docker run. So this you would do through like your command line. So like Docker PS, right? So command line tool here. So that issues commands to the daemon that's constantly running. And you can pull images out and deploy them to individual containers on the machines. And then I don't know what registries for, I guess, their official registry of all the different images that exist. So I'm not sure if like anyone can contribute to this or what, but this one is for Redis. I've used Redis in the past with Docker, and it works really, really well. So, okay, that's neat. This all makes sense. It's pretty sane so far. Let's keep on going. So let's learn about the daemon. So the Docker daemon, Docker D. So I want to write that down. Docker D is equal to the daemon. When you use commands such as docker run, the client sends these commands to Docker D, which carries them out. The Docker command uses the Docker API. Okay, so when you say Docker, you're just using the API. Using the API. Okay, so the Docker client can communicate with more than just one daemon. Docker client communicate. Yeah, I guess this makes sense. Based on what they set up here, you can connect to a remote daemon. So this is logically true. Okay, so registries. A Docker registry stores Docker images. Docker Hub is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. You can even host your own private. Okay, that's cool. So in case like if your organization has their own kind of private repository where they want to store custom containers or custom images for just your organization, then you can set up your own private registry. Similarly, you can do that with like a GitHub private repo. Some comments from the chat. Hi, Tarun. How are you? Thanks for stopping by. And if you're just joining, feel free to ask any questions or correct me on anything here, taking this from a pretty fresh perspective. So Docker objects. When you use Docker, you are creating and using images, containers, networks, blah, 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 blah. This session's a brief overview. So images. So images, a read-only template. So I'm probably gonna need a section here. Images. Make some room for myself. Okay. Read-only template with instructions for creating a container. RO with instructions for creating container. An image is based on another image. Ooh. So does that mean that there's like parent-child relationships? Maybe. An image can be based on another image, right? You can build an image which is based on the Ubuntu image, but installs the Apache web server and your application, as well as their configuration details needed to make your application run. You may create your own image, or you may only use those created by others and publish in a registry. To build your own, you create the Docker file with a simple syntax for defining the steps and to create the image around it. Each instruction in Docker file creates a layer in the image. Okay, so a layer in the image. So you have a concept of instructions, creates layers in the image. And what else did we say? We said images, oh, I already have that. Can be based on other images. They can be like parent-child relationships, right? Sounds like that's what they're saying here. Each instruction, when you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. Okay, so this is a neat little optimization they do, so you don't have to rebuild everything when one thing changes. This is part of what makes images so lightweight, small, and fast when compared to other virtualization technologies. Okay. Containers. So containers. Love this Let's Learn series. Great videos. Thank you, RoPro. I kind of based them off of, like a lot of video games have Let's Play series, especially if you're into like Civilization or any kind of real-time strategy games. There's a lot of stuff like that. So that's what I'm kind of basing it off of. I find some folks don't like to admit that they don't know something, so they don't really want to expose that fact. But if you don't know something, then you should just be trying to teach yourself that thing. So I'm happy to show what I do and do not know, and Docker isn't one of them. And I was just telling the chat earlier when I first started this video, the reason I don't know Docker, I think that most people at least know about it, but maybe know how to use it in its basic form. The reason I don't is because at my job, we kind of build everything from scratch. We have our own build system and everything. So I've kind of been detached from the outside world for 6 years, 5 years, something like that. So I'm trying to see what other people are doing in normal development land. Yeah, awesome idea. Wish I had these when I was learning. I know, me too, man. Honestly, it's great to watch other people go through the same processes and learn these things, because I'm kind of digesting this at a pretty slow pace. So hopefully I'm not going too slow for you all, but let me know if you want me to improve or go a little quicker. Anyways, containers. So a container is a runnable instance of an image. Let's just get that down. Runnable instance of image. You can create, start, stop, move, or delete a container using the Docker API or CLI. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. I just want to read that again. Connect a container to one or more networks, attach storage to it, create a new image based on its current state. Okay, so you can kind of fork off of whatever it's doing right now. Interesting. So by default, a container is relatively well isolated from other containers and its host machine. You can control how isolated a container's network, storage, or other underlying subsystems are from other containers or from the host machine. Hold on, I want to read that again. Well isolated, how isolated, or from the containers. Okay, so I was under the initial impression that they were completely isolated, these containers, from one another. So that doesn't seem to be true. So maybe I need to learn a little more. So a container is defined by its image as well as any configuration options you provide to it when you create or start it. When a Docker container is removed, any changes to its state are not stored in persistent storage disappear. Okay. So an example Docker run command. Following command runs a Ubuntu container, attaches interactively to your local command line session, and runs bin bash. I suppose I is for interactive, T is for I don't know. And we're running Ubuntu. Oh, okay, so and you can specify a startup command. Okay, that's cool. I want to keep this. Let me just write a note to myself. So above, what are we doing here? So we're run Ubuntu container. Run Ubuntu image in a container and run the bin bash startup command, right? I guess it just runs bin bash. Okay, when you run this command, the following happens, assuming you are using the default registry. If you do not have the Ubuntu image locally, Docker pulls it from your configure registry as though you had run Docker pull. Oh, okay, I didn't know it did that automatically. It creates a new container as though you had run a Docker container create command manually. Okay. And Docker allocates a read-write file system to the container as its final layer. This allows a running container to create or modify files and directories in its file system. So I wonder, like, how do you specify the resources for each container? Like, where do you specify that it's 2 gigabytes of memory or whatever you want to specify? Is that in the config file? I would assume. So maybe let's just keep a section here for open questions that I want to answer. Where do we specify the resources of the container? Maybe chat can answer that if someone else knows. There's some couple comments in chat. So Tarun is asking, what's the difference between virtual machine and Docker? Leon, I actually don't know. So good thing that Leon answered the question. Virtual machines are on top of a hypervisor. Okay. Containers aren't on top of a hypervisor. Containers have less overhead because it doesn't have to create its own OS. Yeah, so it uses the host system. Yeah, so this kind of seems pretty neat. Thanks for clarifying this, Neon. So you don't need to spin up a whole instance. So if you're using something like VMware, you usually have to boot up like an instance of Ubuntu or of Windows or Mac. I don't even know if you can use Mac for VMware. But there's a lot of overhead that goes into that, just launching your OS and your file system. Just launching your OS. So it seems like Docker just runs within your Windows instance. In this case, it's on a Windows machine, and it saves you that overhead, but it also gets some dedicated resources so no other processes are going to screw with you. And Leon is saying you can specify the volume size. And Leon, does that happen inside of your config file? Or where does that happen? I may come to that, so maybe you don't have to answer it now, but I'll check in a few minutes on the chat. So Docker allocates a read write. Okay, I already read that. Creates a network interface to connect the container to the default network since you did not specify any networking options. This includes assigning an IP address to the container. By default, containers can connect to external networks using the host machine's network connection. So I suppose here you can wrap it with some custom network configuration if you don't want it to be able to talk with anything in the outside network, and you only want it to be able to receive traffic on certain ports. Seems like you can specify that in the network interface section. Again, I'm not really sure where that happens yet. Let's leave that not as an open question. Let me just scroll up so you guys can see everything. Okay. So it starts the container and executes bin bash because the container is running interactively and attached to your terminal due to the I and T flags. You can provide input using your keyboard while the output is logged to your terminal. When you type exit to terminate the bin bash command, the container stops but is not removed. You can start it again to remove it. Oh, okay. So using that command, I mean, it just gives you a terminal basically in which you can interact with the container instance. So it's not really doing anything. It's just kind of getting your terminal set up so that you can interact with the Ubuntu instance in this case. Okay, services. I don't know if I'm going to need a section on this, but let's just make one just in case. Services allow you to scale containers across multiple Docker daemons. Ooh, so this is where the scalability part comes, huh? Which all work together as a swarm with multiple managers and workers. Okay, so this is interesting. So this is, I guess, how it scales. So services allow you to scale across multiple daemons, possibly on other machines, right? What else? Oh, this is called a swarm. And each member of a swarm is a Docker daemon, and all daemons communicate using the Docker API. Oh, okay. So a swarm is like a group of Dockers that are working together, and a swarm has one daemon, and there's multiple containers that are issuing commands to that daemon. So it seems like in a swarm, you can have multiple machines. Your daemon is the orchestrator for all the other different containers that are running in it. That's at least how I understand it. So let me write that down because that's how I'm going to remember it. So you can have a swarm, which is a grouping of containers. This grouping is orchestrated. Make this a little bigger. Whoa, what happened here? I can't make this the right size where it doesn't cut everything off. Sorry. This grouping is orchestrated by a single daemon, right? That I guess manages the swarm, probably. So that's what we got so far. So a service allows you to define the desired states, such as a number of replicas of the service that must be available at any given time. By default, the service is load balanced across all worker nodes. Wow, this is cool. So let me explain how you would typically achieve this kind of behavior using something like EC2 machines. If you're just starting a Node.js application, like an Express app or something on EC2 and AWS. So you'd set up all your EC2 machines, right? And then you'd maybe put them in different availability zones. So let's say you have 9 machines that are going to host an application. Now the question is, how do you actually scale? Like you have scale in the sense that you have multiple different instances, but then the question becomes, how do you route traffic correctly? So that you kind of get, if you have 9 machines and traffic's coming down this way, you want a request to hit one of the 9 machines, and you want it to be pretty much random every time. And be running health checks to make sure all 9 are good. So how you do this in AWS is you'd set up your EC2 machines, all 9 of them. You'd put a load balancer in front of them, And then you'd put, the load balancer would map to a target group, and the target group points to the 9 machines. And that's how you kind of achieve scale there. And on the load balancer, you specify the number of the ports where it's going to forward traffic. And then when you make a request, you're basically just hitting a load balancer now, and then that's automatically being routed to the correct, well, not correct, but any instance since they're identical. So it seems like by default, Docker does this just out of the box. So this is like one of the big problems with, I'm just going to copy paste that because it's so clear. So this is one of the big problems with just managing any distributed application. It's that scaling can sometimes be a bit of a tricky problem, especially if you want to maintain fine-grained control over your application. So I'm seeing here a potential vulnerability in the sense that if you're using EC2, you get full flexibility, full control, do whatever you want. If you use Docker, you relinquish some of that control in favor of having an easier time to kind of deploy quickly and build quickly and scale quickly and all the good stuff that seems to come with it. So that's pretty cool. Services are pretty awesome. So the underlying technology. So it's written in Go and takes advantage of several features. Okay. Uses namespaces to provide isolated workspaces called a container. Excuse me. When you run a container, Docker creates a set of namespaces for that container. They provide a layer of isolation. Each aspect of the container runs in a separate namespace, and its access is limited to that namespace. So this isn't really relevant for this discussion, but I guess if you really want to know how it works under the hood, this may be cool. So it uses the concept of PIDs, net, okay, for networking, IPC. Okay, so this isn't really relevant. I don't really care about this. What about control groups? Control groups. So this is just discussing the logical isolation of the resources and sharing, I suppose, some hardware. You can limit the memory available to a specific container. So this is kind of what I was saying in the beginning. So it looks like this feature is only available on Linux. So very isolated resources in the sense that you allocate, maybe you've got 3 containers on your machine and you have, I don't know, 9, well, it's a weird number for memory, but say you have 9 gigabytes of memory and you want to divide evenly, so 3 gigabytes each, then I'm not sure, like on Linux, it seems like the 3 gigabytes are for each container, but maybe on Mac and Windows, that's not the case. But since you're probably going to be deploying on Linux in most production environments, this seems like an okay thing, not a big deal. And if you're not using Linux, you probably should. As I say this from a Windows machine, slap me on the back, I know. Just going to check out the chat really quick. You can specify the volume size. Cool. It should just be specified most likely through the Docker compose or through the Docker command. Okay, cool. So we can specify the parameters of our containers. A bit of a digression. Kubernetes uses this well, but it can be pretty complex. I think Leon is referring to the scalability component. And I hope to learn about Kubernetes a little bit more after this as well, because I've heard that heard some positive things about it. And I know that it's related to Docker, but I don't really know the kind of low level, like why it's important or what it does. Okay, so this is pretty good for a start. What else we got here? So quick start, orientation and setup. Ooh, video. Should we watch the video? How long is it? 28 minutes. Okay, let's give it 5 minutes, and if it's good, we commit. If it's not, we roll this puppy back, and maybe we watch something else or just continue down here. Make this big so you guys can see. That looks good.
Everybody,
let me know if you can't hear, by the way.
My name is Peter McKee. I'm on the developer relations team here at Docker. And you can follow me at pmckee on Twitter.
We're going to fast forward.
Up to date, you have to patch them. Well, there's a problem right now. We have a lot of individual machines, VMs running, with OSs running in those, whether it's on bare metal or inside of a VM.
I'm just going to speed this guy up or else we're going to be here all day. Let's try 1.25. What is happening, YouTube?
And these operating systems are hard to maintain. They're hard to keep up to date. You have to patch them with security patches. You have to install all the dependencies. And you have to upgrade the operating system. And then you have to install your application code on it and configure that. I used to work at a large computer manufacturing company here in Austin. I won't mention the name, but we had hundreds of servers in our data center just for the e-commerce platform that I worked on. And you can see here on the screen that we had over 100 servers just for our browse and our www layer, 50 in each data center, 100 for being able to configure your purchases. So when you would go onto the www layer and find a laptop that you liked, and then you would choose it, and then you could configure it, add memory
I know exactly how this guy's feels. This is like how you used to have to do it. It was a nightmare.
to it and those type of things. So we had hundreds of servers there, 50 plus in each data center. And those are just two of the services we have. We have multiples, right? And these machines were very hard to keep up to date.
We don't know how good we have it these days, by the way. I just want to call that out. You can go on like these, Google Cloud Platform or AWS or Azure and just click buttons and instantly get hardware. It's like insanely easy these days. But like this guy is saying, like this is what you had to do back in the day.
We had scripts that we'd run to update these and deploy application code to install security patches. But we had to keep a list of the servers in a file, and sometimes that list wasn't always kept up to date. Someone would fat finger a server. So this led, not all the machines would get updated, right, when we tried to update them, even with application code or a security patch. And this led to intermittent errors. So a user would come to the website, they would see a laptop that they liked, and they would choose that, and that request would go to a server. Well, if that request hit a bad server, they would get an error. And so what the user would usually do is just hit refresh, and that request would go to another server, and that server could have been fine.
Who has ever had the just refresh your browser and it'll work kind of experience? Because, I'll put my hand up. I've been there, done that. Obviously not a very good user experience, but, it happens.
And from there on out, they could hit all normal servers the whole way out. And we would get these errors, and it was because one of the 50 servers in the data center wasn't configured correctly. And so to try and troubleshoot this was a nightmare. You had to look at multiple layers. So we really thought of our servers as pets. We wanted them to stay up and running for long times, 5 nines uptime. And when one went down, we'd pull it out of the layer, we'd try and fix it and heal it and put it back into the layer. And it was just really hard. Well, Docker has a solution to that, and containers are a solution. And so what if we could take our application, its OS, all of its dependencies, its configuration dependencies, and bundle that all up, right? And let's call that an image. So you're able to take that image, deploy it out onto a server. You could deploy.
Well, I want to back up there. Bundle all our application code, support binaries, and configure. Okay, that's fair.
Its OS, all of its dependencies, its configuration dependencies, and bundle that all up, right?
Hold on, I'm going to make this a little bit smaller so I can take notes at the same time. Can we just go here? There we go. Whoa. Where was I? 333.
Has a solution to that, and containers are a solution.
Okay.
And so what if we could take our application, its OS, all of its dependencies, its configuration dependencies, and bundle that all up, right? And let's call that an image. So you're able to take that image, deploy it out onto a server. You could deploy multiple images on those servers. And then if one of them goes down or two of them goes down, you just put a new image out there and the application's back up and running. No longer do you have to pull that server out of the system, try and fix it and patch it. You just deployed a new image to it. And these are all copies of each other. So you don't have to individually configure each one of those applications running on those servers. And then we can look at our servers and our applications as ephemeral, short-lived. So if they died or went away, that's okay. We just replace them. Docker really focuses on 3 kind of phases in this new world. So we focus on building images, shipping images, and running images. So if you could build your image and consistently package everything up into one image, then you could easily ship that image anywhere you wanted it. And this
Can you have branches of images? I wonder. That'd be pretty cool.
allows you to, you could ship to a local developer.
I want to add that as an open question. Can we have branches? Someone in chat tell me. So like, I just want to capture this. So phases, build, ship, run.
Another developer that's on your team, and they can easily run that image, right? Consistently run that image. And this leads to all the things you see nowadays. So CI/CD, continuous integration, continuous deployment, being able to run your applications easily and test them through a production stage.
So this largely solves the problem, works on my machine. If you've ever been at any company and someone is troubleshooting a problem, or you're troubleshooting a problem, and they're like, oh, can you try it on your machine to see if it works? And then you're like, oh yeah, it works totally fine on my machine. And the other person looks at you dumbfounded. It's like, what the hell is happening? Why is it working on this guy's machine and not mine? So it seems like Docker kind of solves this problem. So I want to capture that. It solves the works on my machine. I want to call this phenomenon. There's like not GIFs, memes about this on Programmer Humor subreddit if you want to go take a look.
UAT, all those type of things. You can run different versions.
Actually, let's look at this right now. Works on my machine, meme. Oh, there we go. Works on my machine, broken in production. It works on, yeah. Beauty. Oh, wow. Okay, bad language. Okay, we're done. This is live, so we're at the mercy of the internet, which can sometimes not be nice.
Of your application locally. You can run different applications of vendor software. So sometimes I run a different version of Mongo side by side. And it allows you to do things like rolling forward, like I was talking about before. So when your application goes down, or you find a defect in your application, a developer is able to fix it, and then through its CI/CD pipeline, just deploy that new fix, and you don't have to pull it back down, try and fix the code in live in production or anything. And the easiest way to get started with Docker is to download Docker for Desktop. And you can find that. You can see the URL here on the screen. You just go to that website, choose whether you want Mac or Windows, and download it, and follow the install steps. It's very simple to get started. Okay, so let's jump over and take a look at some. What we're looking at here is a Docker file. So a Docker file is used to build your image. So you can think of a Docker file as just a list of commands that get sent to the Docker engine, and the Docker engine starts at the top and reads down through those, executing each one in turn, and builds your image. So the first.
So I just want to pause here and just kind of make some assumptions about what this means before he goes and explains it. So I'm assuming here this is based off of some parent. So this is probably from the registry or whatever it's called. So this file is going to be a descendant of this. So whatever this contains, then this container will obviously contain it. So specify the working directory, the port that it's going to run on. So you're copying wherever you are right now, your package JSON, you're copying it into the code path, running npm install, copy everything where you are into code, and then I guess this is the startup commands. You just run node and use server.js as the target, something like that. Let's see.
First command we're going to give Docker is from. And when you build images, you usually start out with a base image. These are verified images that live up on hub.docker.com.
So that's the base image. That's what I said. Cool.
And you can start with a base image that has everything you already need in it. So this application that we're taking a look at here is a Node application. So I'm going to use the Node base image. So it already has Node installed in it, it has npm installed in it, it has yarn installed in it if you're going to use that. And so we tell Docker, start with that Node image, and then we're going to build on top of it. And so the first command we give it is the from. And we say from node, 12.16.3. 12.16.3 is the tag of the Node image we want to use. 12.16.3 is the latest long-term supported version. And so the from command tells Docker, use this Node version, this image, and we're going to build on top of it. Then we use the working directory. So what the working directory command tells Docker to create this directory /code and use that as our working directory. So all subsequent commands will use that directory. And then on line 5 here, we set up an environment and variable with the env, and we name that variable port, and we assign it 80. And so environment variables will then be able to be accessed by any processes that are running inside your image. And then on line.
I actually want to write down these specific commands so I can run them later, or play with it later. Workdir /code, /code, env, and what did he say? Env port 80. Copy package.json /code/package.json, and then run npm install. And then cmd, so he says cmd node and source/server.js. Yes. Okay.
Line 7 here, we copy in our package.json file, we copy that into the image and we put it into code package.json. Package.json tells Node what modules we want to use, what our application requirements are. And then we use the run command. So everything after the run command, Docker will execute. So it's going to run npm install inside of the image. And npm is the Node package manager. Node package manager will use package.json. Look inside there for a list of dependencies. We'll download those and put those into the image. And then on line 11 here, we copy everything that's in our working directory in the local directory denoted by the dot. It's going to copy all that and put it inside the image in the code directory. There's also this file that you can have on your local machine. It's called a Docker ignore file. If you use a Docker ignore file, it's very, very similar to your get ignore. And you just list out what folders you don't want to be included in your image. So copy will take everything, and I'm using the dot to say in the current directory, take all that and put it into my image. And then on line 13 here, we use the command. The command is used to give the engine the default command that it should run when it starts our container.
Hold on, I want to capture that. So tell Docker to not copy over these files / directories.
So when you tell Docker to run your image as a container, Docker looks at the command and says, oh, okay, I'm going to run node, and I'm going to pass in the node the source server.js, and that's the application. That's the command it's going to give to our image to run. Okay, so we started at the beginning. We used a base image called node. We set up our working directory. We created an environment variable named port. We copied in our package.json, all of our application dependencies. Then we ran an npm install to install those dependencies into the image. And then we copied all of our source code into the code directory. And then we told Docker, call node and pass it in server.js when you start this image. So let's jump over to the command line. Let's build our image. So the way you build an image is there's a Docker build. And I'm going to do run the help so we can see what options you could pass into it. So if you look at it, I want to look at two options real quickly. We have the tag option. And so that's how you name and then optionally give it a tag. And
this is what you were talking about, Leon. You can tag, right? I think that answers one of my opening questions. Oops. But let's see him talk about it.
Into this format. So name, tag. So if we look back at our Docker file, that's what Node did with their image. They said node 12.16.3, right? So we could do the same.
So I guess there's no real branches per se, but I guess tagging lets you, associate different things with it. It's okay.
For our image. And then the second flag here is the file, -- file, and that tells you where the Docker file is located. The default is just whatever the path you give to it. It'll look for the name of Docker file with a capital D. So you can see here we can do Docker build, pass in options, and then we give it a path. So let's go ahead and do that real quick. So we're going to run Docker build -- tag. I'm going to call it hello - world. The path is just going to give that current working directory. Let me show you. Here in our working directory, you can see that we have our Docker file. Okay. So let me do Docker build -- tag. I'm going to give it hello world, and then I'm going to give the path as the local directory. So let's run that. So you can see here what Docker's doing is it pulls in our Docker file and starts executing the commands. Right here, you can see step 1 of 5, and then 2, 3, and down. You can see the from command, the working directory, the copy, and so forth and so on. So it runs all those commands, and then it writes our image and gives it a SHA, and then it'll name our image as hello world. So let's clear the screen real quick. Now see a list of images that you have on your local machine. You can do a Docker images. So there we go. Here's a list of images I have on my machine.
What do I have on my machine? Holy crap. How did I get all this? What do I have here? Redis. Okay. Yeah, I was screwing with Redis the other day. Okay. Oh, I need to remove this. This is taking up 611 megabytes. Come on, Dynamo.
See the hello world image that we just built?
Actually, I want to run that command, or remember that command. Docker images. Oops. Docker. C installed images.
All right. Okay. So next thing, we had our Docker file, which we told Docker how to build our image. We did a Docker build, built our image, and you can see it. We just looked at it. Now we want to run that image. And so Docker has a run command. So do Docker run. I'm going to do -- help so we can take a look at it. Now the run command has a bunch of options you can send into it. You could do things like run it detached. You could set CPU limits. You could tell what DNS to use, all kinds of different things.
So this is what you were talking about, Leon, with the constraints of the the constraints of the hardware. So what do we see here? So CPU quota. No, okay, so you can specify the number of CPUs. Okay, so you can basically do whatever you want here. This is a lot of configuration that you can load in here, like your device write rate, your read rates. So this is cool. You can really tune this to exactly the way that you want it. Is Docker built only for servers, or are there any other applications? So it seems like, granted, I don't know that much, and someone can correct me if I'm wrong here. You can use it for anything from like a local development environment for your developers. Maybe you want to install like a bunch of different things, like a certain IDE or whatever, so that it can be shared across all your developers, so they all have the exact same setup. So you get consistency in that way. Or maybe if you have like a more complex environment that you need some very specific programs and they need to be installed in a very specific way, then Docker is the perfect fit for that, right? Because you just get an image and then someone from your organization keeps it up to date, and then you just run that image and it's going to work exactly the same for everyone. So that seems like it's the big strength. And I think Leon just answered that question as well in the chat. I hope I'm right. Yeah. You can actually just do development in Docker, he says, which is consistent with my understanding.
Right now, we're really just going to very basically run our image.
Oh, wait, what did how did he see all those things? Okay, so when you say Docker run, you can specify a ton of things like hardware, well, it's not really hardware, but it is in the sense that you're telling it how much you can use, like, memory, CPU, IO, network, all that stuff.
You could tell what DNS to use, all kinds of different things. For right now, we're really just going to very basically run our image. So we run Docker run, and then when you just give it the name of the image you want to run. So I'm going to run Docker run hello world. So we run it, and now we're listening on port 80. Let's go over to our handy dandy browser here, and let me refresh. Oh no, nothing's coming up. That's because your containers are run in isolation. So basically, a container is just a process that's isolated from the rest of the system. It has its own file system. It has its own network. It's restricted to its CPU and memory usage. And so we didn't give it any ports. We didn't map out any ports. We didn't connect it to a network. So in the browser, when we try and connect to it, we're not able to connect. So let's do that. So let's give it, real quick, I want to show you. So right now let's look at what's running. So to see if anything is running on your system, you could do a Docker PS. That'll call it processes, PS for processes. And we don't see anything running. But if you do a -A, that will show you everything. And we can see our image that we had run above here in this run command. We could see the image hello world. Here's the container ID, Shaw. And it said it exited about a minute ago. And it gave it this name of crazy Potalomi. If you don't name
It's pronounced Ptolemy.
your images, Docker will name them for you. And so we can see we still have that same image there. So let's remove that image. Well, before I do that, you can also start your Docker images. So let's do Docker start. Just give it the name of the image. And it's back up and running. Let's do a Docker PS. And there we can see that it's running.
Wait, I don't get it. So he did Docker run hello world. He did Docker PS, and that gave nothing. And then he did PS-A, which gave this. And then he ran Docker starts. Oh, okay. So he's specifying this is this the container instance ID? Because you have a container ID over here, and I guess this is like your whatever you want to call it. If you don't specify the name, then it gets given to you. And so you're starting it now. Oh, okay, so now he's doing Docker PS. You see up here, it never returned anything. But after he ran it the second time, and this is because he used the start command, now it's actually showing as a running container when you do PS. But what does -A do? I want to remember that for later. Oh, sorry, you guys can't see the bottom of my screen here. What is this? Docker -A? What is -A? Oh, PS-A shows all processes, even the ones that have ended. Okay, so that's case closed on that one. Thank you, Leon. So So RoPro is saying Docker generates a human-friendly alias. Yeah, so that's the crazy Ptolemy. And I guess you can refer to it by the ID as well if you want. So suppose like you would specify the alias with like a -a on the run, or maybe just after hello world, something like that. But I guess I'll figure that out.
Up 5 seconds ago. So let's stop it. So you can do a Docker stop, and now do a Docker PS again. And we see that it stopped, and if we do a Docker PS -a, we can still see it's there. So let's remove that image now. Let me clear the screen. So we do a Docker remove and give it the name of the image.
Okay, I want to try that on mine. So what did he do? So he did like, so let's get rid of this. So Docker PS. Okay, what? Sorry, I want to go back here. So I have like Redis installed, right? So let me just move this down so I can see what he did a little bit. So, so Docker run Redis, right? Whoa. Okay, so this is the default log. Oh, you know what? Okay, so it is running. So now I have Nostalgic Maxwell. So I did the same thing and it was running, and he did PS and he didn't get it back, but I'm not, maybe it's something to do with my configuration, or maybe like the default Docker, default Redis image may be blowing this up a little bit, but, okay, so -a, okay, so it shows you the same thing. What else did he do? And then Docker stop. I guess I need to refer to Nostalgic Maxwell. Okay, and then Docker PS. Okay, cool. And PS-a. Okay, so we have a container here that is not started up, and it's called Nostalgic Maxwell. So let me try to do this again. So Docker run Redis, and let's give it a name, foobar, or try that. Whoa. How about -n? No. Okay, I'll figure that out later. Redis is still... Is it really running? I don't see it running. Am I wrong, Leon? Do I need to kill each of these? Maybe. Is this even a command? Ooh. Oh, okay, it's not running though. So these are just images, right? Okay, that's fine. Oh, it's like a service. Okay, so Leon's saying it's kind of like a database always running as a server. Oh, okay, so sorry, there's a little bit of a delay in between like when I say things and when you see things. Or when I see them on the chat, I mean, so you may be a few seconds behind. But so now it seems like everything is, like these were the images that I had at some point, and none of them are running anymore. So that's great. So basically my first little powwow with Docker, but let's keep going now.
So let's remove that image now. Let me clear the screen. So we do a Docker remove and give it the name of the image. So now if we do a Docker PS, we won't see it because it's not running. And then we'll do a Docker PS-a, and we can see it's been totally removed. Okay, so let's take a look at their images. So again,
wait, how did he do that?
Yes, we won't see it because it's not running.
Oh, if you do Docker RM, you can get rid of it.
We can see it's been totally removed. Okay, so let's take a look at their images. So again, to see what images are local, you do a Docker images.
Let me write this down because I'm going to screw this up later. So Docker RM gets, what do I want to write here? Gets rid of images, not, yeah, okay, that's fine. Docker PS-a shows you non-running images. Docker PS shows you running images. And then what else do we say? If you don't specify a name, Docker will give you some wacky one. Okay.
So now, remember when I first started it, we weren't able to connect to it in the browser because we didn't allow our container to have any access from the internet. I'm going to expose a port, so I'm going to do a Docker run, and I'm going to do -p. I'm going to give it 8080:80. So I'm going to map port 8080 on the local machine to port 80 inside of the container. Then I'm also going to name it because I don't want Docker just to give it a random name. So let's call it hello. You can run your container in the background detached. So for long running processes, such as Node, a web server, we just want it to run in the background as detached. So we can give it a -d, that'll run it as detached. And then we'll give it the name of the image. And so now we're running. When you do a -d, Docker will spit out the...
All right, I want to get a bunch of things down there because he said a bunch of juicy things. So what did he say? So he said -p, and then in this example, it maps local port 8080 to container port 80, --name, you know, I don't think I even need to say that. It specifies the name of the instance. And -d allows for detached mode, so you don't need to keep your terminal running. That's pretty neat.
container SHA, the container ID. So to see our container running, we do Docker PS. There it is running. You can see the name is hello. And now you can see that we mapped port 8080 into port 80 in the container. So let's go over here.
Where did it say that? Oh, there it is. So local 8080 to 80 on the container. And what did Leon just said? Docker system prune. Docker system prune? Is this a command? Oh boy. I'll stop. Yeah, let's do this. Oh baby. I like that. Lovely. Writing that one down with big stars around it. Docker system prune to get rid of old non-running images. See, now I'm getting the terminology right. Okay. Let's keep going.
And you can see the name is hello. And now you can see that we mapped port 8080 into port 80 in the container.
This is a very useful tutorial, by the way. What's it called? It's unlisted, so it's not. You can't just access it through. Well, I guess you can access it through the URL. I'll put this URL in the notes, which I plan to put on GitHub later, which you guys can take a look at. Good tutorial.
So let's go over here to the browser and let's put in port 8080. And there we go. We can see it running. Now we can stop that. Do a Docker stop. Hello. Okay, it stopped. Now we don't see it. And we do a Docker PS to show us our running processes. It's not there, but if we do a -a, there it is. And again, you could start that container back up, do a Docker start, and we'll just give it hello. And now it's back up and running. And that's how you start and stop your containers. That's how you build images. That's how to connect a port into your image, how to run it in the background. So now that we have it running, what if you run your container in the background and you want to see what logs it's producing? So Docker has a command, Docker logs, and just give it the name of the container. And you can see there, it's listening on port 80. We stopped the server, and then it's listening on port 80 again. You can also run a -f on the logs. So let's look at the help here real quick.
-f on logs is the best command. If you don't know about tail -f, you should know that command to tail logs live in real time.
And you can see a -f or --follow. So that allows you to follow the logs. So if you're running an image locally and you're having a problem with it, you can attach and follow the logs and see all your logs coming out. So let's do that. -f and then give it the name of the container. And now you see it's listening. This application, we're not dumping anything out to the logs. But to get out of watching the logs, you just hit a Control-C. But that did not stop our container. Our container is still running. So let's stop our container. Hello. And then Docker PS-A. We can see it's still there. Let's remove that container. So we Docker remove. Hello. Now we should not have it running. Cool. But we still have our image. So we looked at building an image and running an image. Now let's look at how we can share that image by pushing it up into...
How is this image 1 gigabyte? Well, I guess it was based on all that other stuff, right? All the Node jazz that he brought in. Who knows what's in that? Like, geez.
Hub. So let's go back to our browser and let's take a look at Hub. So Docker Hub is where all your base images can live. It's a repository for images. And it has some auto build capabilities. It has some CI/CD capabilities. It has some organizations and teams where you can set up RBAC, rules-based access control for your teams to give them access to your images. So you need a Docker ID. So you log into hub.docker.com If you don't have a Docker ID, you can sign up right here. Of course, I already have one, so let me go ahead and sign in. Okay, so I'm signed in. This is the dashboard. We see I have 3 repos already. So I'm going to create another repository so we can push our image up into the cloud. So let me create a repo.
This must be the way they make money, right? I can't imagine any other way, unless they provide some other kind of hosting thing. But what's this thing called? Docker Hub for private images and all that.
I'm going to give it the name of Hello World. And you can give it a description if you like. Then you can mark your repos as public or private. You could do auto builds. So if you're connected to GitHub or Bitbucket, every time you push.
That's awesome. So you get like complete, well, not complete, but you can rebuild your images pretty quickly by just connecting the Docker file to Git. That's pretty cool.
You can set up a hub to listen to that, and it'll build your tests for you. It'll run your tests and build your images for you, and then push it into the repo. Okay, so
wow.
We named it Hello World. Let's create it. Okay, so now we have a repository where we can push our image. And you can see up here, there's a tags, and we don't have any tags yet. We don't have any images pushed. Let's go back to general. If you look over here to the right, you can see this Docker push command. And so this is the command we're going to use to push our image up to hub. So now we'll come back to the command line. And let's look at a list of our images right now. You can see the name is Hello World latest. Name of the image needs to have the repo name, pmkey Hello World, and then give it a tag. So if I run this command right now that I took out of hub, so if you look here, here's the command, right? If I tried to run that now, it's going to say, I don't know what image that is, pmkey, right? So what we need to do is we need to tag our Hello World image with pmkey. So we'll run the Docker tag command, and we'll give Hello World. We'll give it pmkey Hello World, right? So now if we look at our Docker images, now we have 2 images here. So you can see we have Hello World and then pmkey Hello World. And so now we can just push that image up in the hub. If you remember back in hub, this is the command right here. So
he basically just renamed his image, like his hello image, to one that matches the namespace of the one that's on the hub.
We're going to do a Docker push.
So that's the lesson, right? If you want to push to hub, your image's namespace must match the namespace as hub.
I'm going to tell it pmkey / Hello World. And now it's going to push that up there. It's pushing all the layers up. Hopefully my internet connection does well, goes fast. It usually is.
Oh, man, I'm jealous of this guy's internet. Look at this thing.
These layers have already been mounted. That means that they're already up in hub. And so Docker kind of looked at it, Hub looked at it and said, oh, we know what this layer is. Don't worry about sending it to us. We already have the node base image up here. And we're almost done.
So that's a cool feature. I don't know if you guys caught it, but it detects change. So it knows that this has already been built, and it'll preserve the artifacts so that it doesn't need to trigger a rebuild. And you don't need to upload it in this case. So that's a good little optimization technique they're running on.
With the last one here. Okay. There we go. Okay. Now if we take a look at our tags, there we go. Now we have the latest tag, and was just pushed up a few minutes ago. So now we could take that, we could plug that into our CI/CD, and we could push that into Stage. We could push that out into AWS, into Google Cloud, into Azure, all different kinds of places. Or you can even set up an image locally that you need to share with a coworker, and you can push that up the hub, and they just pull it back down. Let me show you how to pull. So let me clear my screen. So I'm going to go Docker images.
Hold on. So he's saying once it's here, then it can go to anywhere, right? So I guess there's a command to work with AWS or deploy this to AWS. Maybe you specify an image name or something like that. I guess I'll figure that out after.
Push that out into AWS, into Google Cloud, into Azure, all different kinds of places. Or you can even set up an image locally that you need to share with a coworker, and you can push that up the hub, and they just pull it back down. Let me show you how to pull. So let me clear my screen. So I'm going to go Docker images. I'm going to remove that pmkey Hello World. So I'm going to do Docker RMI to remove the image, and then Hello World. So now it's gone. So let's do Docker images. Let's do a Docker pull. pmkey Hello World. It's using the default tag latest. There we go. It took a look at it, said download the newest. So let's do Docker images. And there we go. We just pulled that image back down. Excellent. Okay, so we took a look at how you build an image using the Docker file, how you set up what you want to get put into your Docker file. We built that image. We took a look at it locally. We ran that image. We exposed some ports. We ran it detached. We looked at logs. We started and stopped and restarted images. And then we pushed them up into the cloud. Now what I want to do is show you how you can take a lot of that and you can run it in using Docker Compose. You can set up your development space to run all these services. So let's say we only have one application here right now, but let's say we're working in a microservices shop, or you just had multiple applications you need to run, or you had a database you needed to run alongside your application. Starting and stopping each one of these containers all the time can get a little bit tedious. Docker has another tool called Docker Compose. What that does is it composes a lot of files together. So if you take a look at this compose file, I have one service, I have the web service, and underneath this build section, I tell it the context, just like the path that we did when we did a Docker build on the command line. I tell it the name of the Docker file, and then I say name the container web, and then expose port 8080, and map that into port 80 inside of the running container. Now what I can do is I can...
Oh, this is great. So no like running crazy commands like that. You just kind of put it all in this one file. It like specifies your build, specifies your ports, specifies all your environment variables and settings and all that stuff. And that makes things super easy. So I want to get that down. So what does it allow you to do? So it allows you to specify, that looked like YAML, if I'm not mistaken. YAML files that define the run specification, it seems like. And it can be one or more services, seems like what that was getting at.
Come over here, back onto the command line, that's clear. And you'll see I have this Docker Compose file right here in the root of my file. So I could do a Docker Compose, and I could say, oh, and I'm going to give it a -d so it'll run in the background. And what it's going to do is it's going to look and say, okay, I don't have any images named web, so I'm going to go ahead and build that. So,
okay, hold on. So what does up do? Docker Compose up. I don't know what it does, but
now it's running down, building everything, running npm install. It'll take a couple minutes. It's pulling down, taking all your npm packages and pulling them down and putting them inside the image. We're almost done here. And now it's copying the source code in. And there we go. That's clear here.
It's kind of cool that you can watch the progress as it goes through all the Docker file steps.
Here, Docker images. We can see here this web. So what Docker Compose does is it looks at your current directory. So docker-hello-world. All the images that you're building from that Docker Compose file, it prepends the name of the directory, does an underscore, and then the name of the service.
Oh, Docker up is Docker run. Okay. Thank you, Leon.
So our name of our service is web. So it took Docker hello world underscore web and created it there. Now remember I did a -d, so let's go see if it's running. And we can see our image is running. It gave it the name of web.
Okay, so Leon just gave me a nice little tip here. Up means run, but for all services in the compose. That's good to know.
In our compose file, we told it name the container web, and it was up 52 seconds ago. And we mapped port 8080 into port 80 inside the container. Now if we come back here, let me change the ports. Okay, now let's try port 8080. Whoop, got to type it right. And there we go, hello Docker. So now cool. to stop your application, we can do a Docker Compose down. That'll stop the web and removed it. If we do a Docker PS, it's not there. If we do a Docker PS-A, it's also been removed. All right, so that's great. We're running our one container. But let's say we had a database, right? So let's go over here. I have another little bit for our database. So I'm just going to paste that over top. So you can see at the top, I still have my service as the web, building the context, same as before. Now I have another service called DB. I'm giving it the image of Mongo 3.6.1, giving it a specific tag. You normally want to give everything a specific tag. And then it says name the container DB, and then I want you to map some volumes. Volumes in Docker is the way we do persistent storage. And so I'm going to say, I want you to create 2 volumes for me. They're named volumes, so MongoDB, and I want you to map that inside of my container to whack data, whack DB. If you know anything about Mongo, that's the default area where Mongo will store all your files. And then we're going to expose our ports. And then the command we want you to run is MongoD. And then down here.
So what I'd like to know is like how this works if you bring down your container. Like I guess it's persistence he mentioned that the volume section was the persistent layer. So will it just by default reload the data that you've put in, or do you need to do anything special? But I guess that's more of a Mongo command than it is really a Docker command. I guess it's more of a, it's on the border.
The bottom, we define those two volumes.
Oh, okay. So he's got volumes here, and then the other one here. Okay.
Let's give them named volumes. Docker will manage the volumes, the storage, everything for us. So let's save that. Let's come back over here, and we're going to do a Docker compose. And we're going to do an up-D again. And you can see Docker's going out. Oh, yeah, Mongo. Let me go pull that image down.
So now it's downloading Mongo and all that extra stuff too.
For you. And there we go. Let's see Docker PS. And now we have our same web app image running. And then now we have Mongo running. So now we could run Robo, which is a little GUI client that connects to Mongo. So let's connect to localhost. You'll see as localhost 27017. Let's go back, look here, see how map the ports.
This is awesome.
Let me connect. And there's my hello world database. And we have all of our connections. All the data is stored. We just spun up a whole Mongo database with just a simple container. Now, you can see how if you had a bunch of services, microservices, even just your front end, your back end in a database. So easy to spin these up. They're all on the same network. They can all connect to each other. And then you're able to share those images out and share this compose out with your fellow developers. They just run your compose file and they have your whole code running, no problem. So covered a lot. We started looking at the problem of why Docker. What does Docker solve? How does it solve it? We talked about we needed to really compose and package up our application and all its resources, the OS files, everything it needs to run. And we did that by doing Docker build. And then we want to be able to run that nice and easily and consistently as many places as we want. And so we did that with Docker Run. And then we want to be able to ship and share those images across the internet into our production and stage environments. And we did that by pushing up into Docker Hub and connecting into the cloud where you can then pull those images down. And then we use Docker Compose locally to spin up multiple containers at once. That's all I have for right now. We only really touched the surface. I know I've gone very fast, but I really, really appreciate your time. Thanks for joining us. And please do check out all the other DockerCon talks. There's a bunch of information.
That was really cool. I'm glad I watched this video, and I'd encourage you to go through the motions just like I did to kind of mess with this, because you learn a lot by doing. So that was neat. Got some hands-on experience there. So how long have I been going here? Oh wow, I've been going for like 2 hours, I think. Is that right? 2 hours? Wow. So I think, let me just see what else this has. So this looks like it's all set up now. And okay, so I think I'm going to pause it right here and leave off and come back next time on a part 2 where I actually like build my own. So I really want to build a Node.js app with a REST endpoint that talks to a MongoDB database. So that's what I'm going to try and build in my next live stream. I may live stream tomorrow or Monday. I'm not really sure yet. Probably tomorrow afternoon at some point. Yeah, thank you everyone for stopping by. I really appreciate it. I learned a lot. I hope you guys learned a lot. But let's just quickly go over my notes here and like see what we did, because we did a lot. So we talked about the Docker daemon and the REST API plus the CLI, which connects to it. You can connect to a daemon that's running on a different machine. We have images, and images are just kind of templates for a configuration that you can specify. They can be based off other images, or so descendants of another image. Then we have containers, which are instances of that image. And then this is an example of running a Ubuntu image in interactive mode. And it's just running bash, the first command that it runs. Now, services are the cool bit, and they allow you to scale. So you can have multiple different containers that are all being orchestrated by a single daemon that can be either on local or somewhere else. And you can also kind of add more workers pretty seamlessly, so it kind of emulates auto scaling. What else? So we saw some syntax. I'm not going to repeat that. We saw how to build it. We saw how to run it. Some basic commands. Port mapping was pretty cool. System prune, Leon, you're the man for giving me this. Thank you for that. You can tag, you can push to the remote repository or the remote hub, whatever they call it. But you need to make sure your namespace matches the namespace of the hub or the entry within the hub. And then Docker Compose is really the thing that allows you to combine multiple different image specifications into one command and bring things all up all at once. So this is really what you'd be using in any kind of real sense. There's probably very rare cases where you're only going to be using one image in your Docker file. And then we had some open questions here. Did we answer this? Where do we specify the resources? Okay, so we answered this. This is in the run command. Run command. And the branches of images, and this is done by tagging. Cool. Sorry. So if you guys are interested, I can share these notes. Let me know down below, and I'll put them in a gist, and I'll share them alongside this video when I post it. But like I said, thanks so much for tuning in, guys. Really appreciate it. I hope you're enjoying the Let's Learn series that I'm putting together. It's all live stuff. My previous one was on Redis. I think I have one. I have another one on something else that I can't remember. But go check out those other ones. And I'm going to be live streaming probably 2-3 times a week. It's kind of fun. And again, thanks so much for joining, and I will talk to you all very soon. I have another video coming out on Monday, another one on Wednesday, another one on Friday. So look forward to those. So I'm just going to stick around in case there's some lingering questions in the chat, but feel free to drop off. RoPro, that was great. Thanks. Looking forward to the next one. Thanks, RoPro. I appreciate you stopping by, and I'm glad you enjoyed it. This is kind of a new thing for me, and it seems to be working well. I mean, there's 6 people on right now, so that's cool. Leon says there was one on Mongo. A tutorial, Leon, I think is what you're talking about? Or like that Docker Compose had Mongo in it. Maybe that's what you're referring to. But yeah. I'm just kind of peruse here just to see what I'm getting into. This is like really big. Is it just me? So we talked about the concepts, we talked about the setup, install, I already have it installed. Building and running, assemble, setup, node bulletin board. So this seems like a node project. That's cool. So maybe I can combine what I learn from this tutorial on that. Oh, you're mentioning, oh, you're right. It was on Mongo. That's what it was. I totally forgot. Yeah, so I have another one on Mongo. That was a good one as well. And I'll definitely be sharing this series and channel with others. Thank you, man. Really appreciate that. It's nice of you. Okay, guys, I'm going to drop off now. Thanks again. I'll talk to you soon and look forward to the next videos coming out. I hope you guys have a great rest of your weekend, and yeah, talk soon. Take care.